Students, welcome to our next video. Okay, so in the previous video we have discussed the layout of thermal power plant. Okay, we have seen how actually the steam flows and how it generates the electricity from where it gets the steams. Okay, so we have seen boiler, superheater, and we will see in this video what is economizer, air preheater. We have seen turbine and how the condenser works. Okay, so in detail we will see this topics again also. Okay, so air supply to the boiler, we will start with this topic. So for combustion of the coil air is required, coal air is required. Okay, for combustion it is taken from atmosphere with the force by draft fan. So from draft, with the help of draft fan, the air is pushed into the boiler, and the air goes to the preheater, right? Let's see here. So this is the forced draft fan. So from the environment it is taking the air and it is going in preheater, so for combustion purpose, right? It helps in increasing the heat. So in preheater, the air is heated by the flow of flue gases. Okay, so flue gases are also flowing through this type. Just see that. One second. Okay, so flue gases are flowing like this. Okay, why flue gases are passed through the superheater? In superheater also there is a steam, right? So we need to increase the pressure and temperature. So with the as flue gases are containing very high temperature, and it also contains some flue gases. So but their heat can be used for superheating the steam. So this superheated steam get heated and pressurized through flue gases, and that flue gas is passed through economizer, and then it is preheated again. That same gases preheats the air from the environment, and that heated air is passed to the boiler, and then the flue gases is forced by the fan in the chimney, which releases it in the very high height through the help of chimney. Okay, so very simple. Okay, so we don't want flue gases because it is unwanted part. Ash handling, right? It is near to the boiler, back of the boiler, and it is removed by ash conveyors to the ash storage. Okay, so flue gases are thrown out through the chimney, and there are many processes inside the chimney. Okay, so cooling water circuit is there. So ample quantity of cooling water is required to condense the steam from turbine in the condenser and maintaining the low pressure in it. So we have to maintain the low pressure of the steam so that the further process can be done. So in condenser, lot of amount of cooling water is needed. If the river or canal is nearby, then cooling can be done very easily. Next one is the coal handling. So how actually the coal is taken inside the thermal power plant. So first part is step 1 is the delivery. Coal is brought from the coal mines, okay, with the help of transportation by rail, road and ships, etc. Unloading of coal at site. So unloading of coal is taken. For this purpose, either coal shaker or accelerator are used, right? So that unwanted part gets removed, and the pure coal should be remained for the process. Rotary car dumper or wagon tippler are also used. Grab buckets are used. Okay, next one is the unloading to the dead storage. Okay, for this purpose either belt conveyor and screw conveyors are used. Okay, bucket elevators are there. Skip hoist may be used. So preparation of coal, suitable size for feeding the boiler. Now we need to separate the coals which are suitable for the boiler. Okay, so coal is random and big size, right? Coal is of random size and big size, which cannot be directly used to the for firing the boiler. With the help of crusher, sizer, dryer, Okay, magnetic separator, it is cut to the usable size. So with the help of these devices we make the coal to the required size. Transfer suitable coal size coal is now transferred by using conveyor belts, screw hoist, or flight cover converts to the storage site. From this place to it is discharged to the firing equipments. Now what are there are actually two types of storage: dead storage and live storage. As the name suggests, the dead storage, the storage of coal is generally coal required for a month, okay, and it is laid directly on the ground. It is directly laid on the ground, and it is required for month usage. Live storage, with the help of bunker and coal means the coal is made available for a day consumption, right? Live storage means the daily usage of coal which is stored in the live storage, indoor live storage. Implant handling, this is the process of handling between the final storage to the final firing equipment. Coal weighing, okay, furnace firing. So these are the steps. Next one is the boiler. So very important, boiler is a major and very important component of the thermal power plant, in which thermal energy produced by the burning the coal is used to convert the water into steam to drive steam turbine, right? So there are mainly two types of boiler: fire tube boiler and water tube boiler. So what is fire tube boiler? In such type of the heat transfer is as follows, right? Hot gases are passed in the tubes, okay, hot fire tube, right? It contains a tube, means in boiler there are tubes which contains the fire. Hot gases are passed in the tubes and water surrounds this tube, okay, means if there, let's suppose this is the tube, okay, and hot gases are in between there, and water is surrounding this tube, right? So this is the fire tube. A shell supports this tube, okay. Heat from the hot gases is transferred to the water to produce steam, right? That this is the gases, and outer there will be water. So this steam, these gases inside the tube will heat the water, and due to the heating the water will release steam, right? So that steam is used. The hot water from the gas is transferred to the water to produce steam. Pressure of the steam is lesser in such system, and it is about 17.5 kilograms per centimeter square. Steam formation is approximately 9,000 kg per hour. So what are the advantages of fire tube boiler? Cheaper in cost, very compact. The greater advantage is that the fluctuation in steam demands can be very easily met. Okay, if there are fluctuations in the steam, then this kind of fire tube type boiler can be widely used. But there are many drawbacks. Steam formed is not that dry but somewhat wet. Time required for large steam formation is very more, right? So it's actually producing very small amount of steam. So steam is very less. Steam pressure is very low. Output of the fire tube boiler is much small and limited. Okay, so these are some disadvantages and advantages. Next one is the water tube boiler. These boilers have smaller drums and tubes. Okay, smaller drums and tube. It is opposite to that. Okay, let's suppose this is a tube. Okay, in the previous there was in between gas, right? But in this case there will be water. Inside there will be water, and outside there will be gas. Means due to this heating, the water inside the get heated and it will produce steam. That steam is then passed to the turbine. Weight, these boilers have smaller drum and tubes, right? It as compared to the fire tube, it has smaller drums and tubes. Weight of the metal is therefore less, and the rare possibility of explosion. Steam produced is very high, right? It is 125 kg per centimeter squared as compared to 17.5 kg per centimeter square, and temperature is 300 degrees Celsius to 575 degrees Celsius. Heat transfer is through wall of the tubes and drums. In boiler, actually there are suppose this is the boiler, and on the walls actually the tubes are fitted. Okay, on the walls this the tubes are fitted, and in between there is a water flow of water, and here the gas will be there. Burning the coal will cause the gas to flow upward and will impact this metal pipes and will heat the water, and due to this heating the steam will be released. Okay, so there is special arrangement, right? For proper burning of coal, air is supplied through FD fan. So let's compare fire tube and water tube. So capacity, fire tube has smaller capacity as compared with the water tube. Sustainability for small plant and is for big plant. Steam pressure is as we have seen 17.5 kg per centimeter square, and it has 300 to 575. Output small and limited, large output. Use rarely used, right? Commonly used. Steam formed, not that dry but wet, completely dry. We want completely dry. Next one is the chimney, right? The chimney is to release the flue gases at the higher level into the atmosphere. So no need to explain. Okay, you must have seen that there are actually large chimneys are there which releases, right? So with the help of fan will push that flue gases inside, and there will be some cooling arrangement will be there. It will spray the water on that gas and remove the bigger particle, and it will deposit at the bottom. Okay, and the lighter part of the gas will flow upward, and it gets released into the air. Now next one is the superheater. The steam produced in the boiler is not dry. Okay, so but we want the dry. The steam produced in the boiler is not dry, but it is wet, containing some moisture. Okay, it contains some moisture. With the help of the flue gases, heat makes the steam dry to be supplied. Right? We don't want any kind of moisture in the steam. Okay, so that steam is released is again heated, superheated through superheater with the help of flue gases. So these flue gases are actually used for heating purpose only. It does not have any other usage. Thus it helps in increasing the efficiency, right? Automatically the efficiency get increased. Some important parts, okay. Next for the economizer. So what is economizer? As seen in the block diagram. So this is the economizer. This component is placed in the way of flue gases and the water inlet to the boiler. I'll show where it is. Right, economizer boiler, right? Here it is economizer. It is between superheater and air preheater. Means it has some uses. Let's discuss. Okay, it is placed in the way of flue gases and the water inlet to the boiler. Okay, so its function is to make the use of heat energy of the flue gases to increase the inlet water to be fed to the boiler, right? Means as I have said in the superheater, that it actually means the flue gases heat is extracted, right? Means if we directly release that flue gases in the air, it has very high pressure and temperature. So why we cannot use that flue gases high temperature to heat the water, right? That heat is extracted in the water, so that efficiency is directly increased, right? So in economizer actually the heat flue gases heat is directly fed to the boiler for boiling purpose. Its function is to make the use of heat energy of flue gases to increase the inlet water to be fed to the boiler, right? By this provision, rate of producing steam is in the boiler will be increased, right? So rate of, with the help of this flue gases heat, we are increasing more heat in the boiler, and efficiency is directly. So economizer can also be called as heat exchanger, right? So this is flue gases are there, feed water inlet, right, through which the water is fed. Okay, and this is through which the feed water is fed to the boiler, and this flue gases is, heat is energy, releases its heating and pressurized energy to the water inside the tubes, and it is then again taken out and released into the chimney, right. So very simple. What is economizer? Construction: a medium pressure boiler economizer is made up of cast iron, right. It is made up of cast iron. For high pressure boiler, it is made up of steel tubes. If it is high pressure, then it is made up of steel tubes. The loops forms by continuous tubes, right. These are actually the continuous, no gaps will be there. Okay, design of economizer says that gas comes in contact with the entire heating surface area. So the tubes are made like that entire heat produced through the flue gases is touched with the surface of the tubes, so that all the heat from the gas can be extracted successfully. To avoid accumulation of dust, the surface is polished, right. So to avoid dust, polished surface is used. Size is compact and easy for maintenance. Gas velocity is maintained constant throughout the passage. Advantages: what are the? It improves the boiler efficiency per 5 degrees Celsius. And rise in fed water temperature efficiency can be increased by 1%. It reduces the temperature stresses, right. It reduces the temperature stresses. Next one is the condenser. So what is condenser? Condenser looks like this. Okay, so it is an important part in the thermal power plant. It is located near the turbine to receive exhaust steam from the turbine, right. After turbine, it comes to the condenser. In the condenser, exhaust pressure of the steam is decreased below the atmospheric pressure. Its pressure gets decreased in this. Condenser condenses the steam. It is cooled by the cooled water, and the same is fed back to the boiler through economizer. So this is good and pure water, feed water to the boiler. This helps in increasing the efficiency of power plant. This also helps in reducing the capacity of water softening plant, right. It also removes air and non-condensable gases from the steam when passes through the condenser. Okay, so there are actually two types of condenser: jet condenser and surface condenser. What is jet condenser? For cooling, cold water is pumped into the storage, pumped into the condenser. Steam exhausted from the turbine enters the condenser and cooled dam to the form condenser, right. Means the dam or cold water is used as a condenser. It is sent to the feed water heater to economizer to the boil. Next one is the surface condenser. Surface condenser are usually universally used in steam turbine power plant, right. It is actually universal single pass, two pass condenser. So this is how actually the condenser exhaust from the engine, condensate to the extraction pump. So this is how actually the condenser, cooling outlet, cooling water outlet, cooling water inlet. Cooling is pumped in the water, and it is cooling water is water outlet. Cast iron shell, right. We have some cast iron shell, cover point, plate, water box, brass tubes. So it consists of cast iron shell in the circular shape. Okay, it is a circular shape. The two ends are covered by cover plate. A nest of brass tubes is fixed to the two tubes plates at the end. The space between the tubes plates and cover plates are known as water boxes, right. So here actually the water will be available, water boxes. One of the two water boxes have baffle partitioning, right. It is a baffle partitioning, right. Yeah, see this is a baffle partitioning. Okay, it flows downward surrounding the cold water tubes. The steam first comes in the contact with the tubes containing comparatively hot water, which has been progressively heated by the condensing steam, and is then passes down, and it is effectively condensed by cold water in the tubes before being removed by the extraction pump and sent to the water heater, and then it is to the economizer to feed the boiler. So it is also an important part, condenser. Okay, next video we will see what is cooling tower. Okay, some more details about the cooling power, how actually the thermal power plants look like, advantages, disadvantages. Okay, then we will move to the diesel power plant. Okay, so very simple. Okay, if you want some details, you can search on YouTube. You will get many videos related to the thermal power plants. Okay, so in this video I have explained some working, right? So in the next video we will discuss more about this thermal power plant. So thank you for watching. Have a nice day.